be able to share your screen there. That should share the presentation.
Let me see. Yeah, here we go.
Yep. And then I think I can start recording from out
Okay,
there.
cool. Yep, sounds great. Thank you.
No problem.
Great. Let's wait for a couple more minutes for others to join. So feel free to take a break. Sure. Thank you. Okay, thank you. Toast already set. They're coming back. Thank you.
We should be just going online, I guess, for everybody.
Okay, cool.
No problem.
So we will get started in, let's say, 2 minutes. Let other people to join, come back.
Yeah, it's kind of like. Basically, like pilot description sound like similar to. Yeah. Yeah.
All right, we can get started. Hello, everyone. It will be our last talk today. So I'm Steve. I'm a senior solution architect with AWS. I have been with AWS over 4 years. I got a research background prior to joining AWS. I work at NIH. So I can talk about my personal experience, how I ended up working at AWS, and how I found cloud computing is the most useful, I would say, technology for researchers, my personal experience. So I work at NIH. There's a center at NIH. NIH is short for National Institute for Health. So for people to do biomedical, bioinformatic research. And there's a center called NCBI, National Center for Biotechnology, biotechnology center information. I work there. They have a bunch of database, chemical, biological database, and my job will be understand those data, right? Do data mining, find knowledge, and share with others. So NIH at that time, that was like 10 years ago. At that time, the government institute at NIH, they are not a big fan of cloud computing. Right? At that time, they think, oh, we do have data centers. So NCBI, for example, have 2 data centers, right? Colo in Virginia, and they have been running it for over 10 years. They know how to operate data center on their own. So not a big fan of cloud computing at that time. But now, all this NIH and other research institute and government, they collaborate with us, right? There's a private-public collaboration to sponsor research running on public cloud on AWS. So it's totally different. So at that time, I do research, our database running our data center, but I need to go to a conference in UK, right? That's far away. I have what I want to show people. There's a hackathon. I want to show people how to run a new query called Spark QL query on top of our biological data. There's over 500 gigabytes of them. Well, that's only a subset, right? I can bring even more data to them. I want to let people to experiment in the hackathon, query and run computation on the data. There's no way to do that. You think about how far it is, right? For people to run interactive query, the data located in Virginia, that's impossible. So I need to find a way to bring the data close to them. So I'm the first, I would say, early adopter at that time at NIH to use AWS to share data, right? Bring environment and collaborate with others in a different country. So you can see at that time I found it very useful, right? I can copy data over from Virginia. Well, it's public data, first of all. It's publicly available, people can download, but using the AWS network bandwidth, right? The network the backbone, I can easily copy hundreds of gigabytes of data over to a different region, different country, and share people how to do it interactively running query, right? So that's my experience. That's like over 10 years ago. I found this very useful. It's pretty cool, right? And if you follow how AWS grow over years recently, they grow very fast, dramatically, right? So I feel it's fascinating. I really want to work here. So I keep learning and doing more building stuff. AWS design for builders. I believe you can build fantastic project on AWS. You are young, smart. You can definitely, if you have idea, talk to us, right? We can find a way, say which AWS, at the beginning you may feel AWS kind of overwhelming, but as long as you keep getting your hands dirty, right? Keep building, you will learn more and more. So that's my experience, how I found cloud computing very useful. And my talk today about AML, we already talk a lot about AML, right? In robotics, the use case in fulfillment center, right? I'm going to talk about AML in a highly regulated industry, healthcare, life science, right? It's I would say the slowest moving industry because there's a lot of people talk about privacy concern, right? Regulation, a lot of that. But even in healthcare, life science, people starting adopting AML. So it's in every industry now. There may be overlap. Feel free to ask your questions. We do have a free book to give away for people asking questions. So yeah, feel free to stop me if you have any question. So first, I want to share this slide with you. It's showing our AWS AML offerings. It's basically in 3 tier. So the bottom tier, I start with the bottom. The bottom tier showing you can run those popular AI ML framework, right? Open source one on AWS. It's all supported. And the AWS has a machine, we call it virtual machine. The GPU have GPU enabled, right? The CUDA enabled instance to run those deep learning algorithms. And AWS provides the broadest and deepest support to those virtual machines running deep learning algorithm. And we also build our own chip, like running inferentia. So running those AML inference fast, performant way, right? So that's the bottom layer. And if people, like we want to democratize AML to everyone, let everyone use it, right? If people like data scientists, they have the science problem they want to solve, right? They are not programmer. They don't want to spend a lot of time just focusing on the infrastructure, start a machine, install all the library, right? Maintain it, make sure this environment I can reuse every time I log in. So we do have like a data scientist platform, managed data science platform called SageMaker. We talked about SageMaker earlier today. So you can, later on I'm gonna show you, there are slides to show you SageMaker really can be used in every step of machine learning lifecycle. We have tool to enable to do that. So that's the middle layer, SageMaker. It's a platform for people who are already familiar with Jupyter Notebook, right? Jupyter Lab environment. They know programming language Python, right? They know they have idea, they have a machine learning idea. They want to run experiment. They can use Python, Jupyter Notebook. SageMaker should look pretty familiar and a very good starting point. And the top layer will be all the managed AI ML services. By managed, I mean they are pre-trained model, right? You don't need to bring your data to train model. The model already been trained. They are being used just through API call. So if you have engineer background, you should be familiar with this API, right? That's people commonly use in industry how they want to get some service, right? Interactive, like backend service. Can be AML backend service, like the use case like speech to text. So I can show you later on a demo. We have built application using this speech to text technology. It's an AML model, right? While I'm speaking, we can convert it to text, and we can run natural language processing model and do other analysis, right? Those are managed AI services. You don't need to build model already trained. You just call the API to use it. So pretty easy to use. So this basically 3 tier of AML offerings from AWS. So this will be the top tier. You can see they have been they are covering different use cases. Let's say in healthcare, life science, those are the ones I would like to highlight. There's a transcribe basically our speech to text AI service. There's a transcribe medical. It's the same speech to text, but the vocabulary is medical terminology, right? We all know there's a bunch of hard pronounce names, right? Disease names are organs, right? Something like that. So those vocabulary domain specific, we have this transcribe medical in medical domain specific, right? Comprehend medical is our natural language processing AI service for medical domain. So specific, like I want to identify all the medications in my clinical notes or my insurance claim report or something like that. Our disease name, right? There are also recognition. Recognition is like our image AI service. Basically, you can run. I want to do object detection, right? I want to do image classification. are doing like I can analysis of video, like I'm teleconferencing to someone, I want to see the sentiments analysis. Is it happy or sad or has some concern? So those are AI services. There are AI model already built in, right? Can run this analysis. You can just use it. You don't need to build your own model to do that. And Poly is our text to speech. So you can just write free text, let Poly to read it out and interact with people, like people talk on the phone, or they call it, or they join a conference, right? Something like that, like chatbot. Use Poly to speak out. There's other AI services like Translate. There's hundreds of language we can support the different translation, right? Text track is our OCR. Basically, if you have an image or you have a PDF, you want to grab the text from the image or PDF, you can run this OCR. It's also a pre-built model. Works pretty well. We have benchmark demonstrated it works better than the open source one. So that's our managed AI service. Amazon Kendra is a search engine. So you can see there are different applications, and we provide this managed API. You can just find the right API to call to achieve those the use case you want to use it, right? Are there for industrial AML application? There's a focus, personalized, fraud detector, and so on. There are plenty of them, and we keep innovating and build other AI services, managed AI services. So quickly, I want to show you one of the demo we have built. This is a telemedication use case. We built this tool totally on AWS. We use AWS, there's a Chime SDK for telemedicine tool. It's like Zoom, right? Our Microsoft Teams. And we use the managed AI services. There's a transcribe medical. First, you can transcribe the speech to text, right? Like closed captioning. So you forget that. And then we run comprehend medical to identify the medication, disease, symptoms. Those are very important information for a doctor to write clinical notes. So I'm not sure if you have this experience visit a doctor, right? You wait there 30 minutes, doctor come in, talk with you like 5-10 minutes. While they are talking, the most of the time they focus on writing notes, right? So that's not good, right? We want to free up those doctors. They let them focus on talking with patients rather than writing notes. Writing notes very important. They need to put this in the clinical, the EHR system, the electronic health record system. Very important for them, but they don't need to spend too much time on writing notes. They should focus more on conversation. So that's, we can, with these tools, the AI service, the transcription, the comprehension, we can automatically generate the clinical notes. That will be the SOAP note on the left. On the left, you can see SOAP notes. Those are automatically populated clinical notes for doctor. So doctor just focus on the conversation with patient. Let me run this. Hopefully, you can hear it. I believe it will go through my speaker on my laptop. So how does it work?
Hi, Mr. Tran. It's nice to see you again. Today, we're following up on your bronchitis.
Hello, doctor. Things are a lot better. Thank you.
Have you been using your albuterol inhaler and any other over-the-counter medicines?
Yes, I've been taking the albuterol inhaler about 3 times per day, as well as taking Nasonex.
How do you feel overall?
I feel a lot better, and I think I'm almost clear of it.
Very good. Keep going as you are and call back and let me know if anything gets worse.
Will do.
Do you have any other concerns?
No, I'm good.
So this is a quick demo to show that you can see through the transcribe medical, we can identify, we can get question?
Is this a web app that?
Yes, web app.
And is it generated is it like a drag and drop thing that you can generate through the platform, or did you?
Currently, it's not a drag and drop, but we are working on that to develop this no code, low code type of platform. Right now, it's really just a builder tool. You need to write this is a React application, right? Write the code to do that. Yeah.
So with the highlighting the named entities and all of that, the programmer has to do that.
Right, exactly.
So for the text-to-speech recognition,
Mhm.
if there are vocabulary that aren't within the library, does the user have the ability to add those new vocabulary?
Exactly, good question. We can. So that's definitely our customer looking for. They are different domain knowledge, right? They can bring their own custom vocabulary to transcribe. So make transcribe better for their own domain specific vocabulary. Yeah, totally. So for this case, I use transcribe medical, so you can see the term like tripodas, ibuprofen, or other, right? Those domain-specific terms, we use this transcribe medical to do that. So this is a quick demo to show the application people can build on AWS using those manager AI. They don't need to train their own machine learning model. They can just use the API. So next, I'm going to talk about SageMaker. Yeah, question.
Okay, so I was going to ask, so is this a multilingual model? So you know how like a lot of people.
Right, transcribe support multi-language. You can select. So that one is English. You can
within the same conversation.
Within the same conversation, not like that. So you need to set up when you start the transcribe job, like I want to stream the audio now, like this through WebSocket, right? I want to send the audio stream. When you start that job, you need to say which language I'm sending to. So, well, what you can do, let's say, well, in this application, it's only English, right? What you can build, you can say, one speaker speak English. I definitely know. Speaker one speak English. Speaker two speak Spanish, right? Mm-hmm. So when speaker one start, I will say I start streaming audio. This is English, right? When speakers when it's finished, I finish the job. I start a new job for speaker two, so Spanish. That's possible. But if they say both of them, right, two speaker in the same audio stream, say I have English and Spanish speaker in this audio stream, it cannot do both. So the result will look pretty weird, right, for Spanish speaking, right, the transcription. You have a question?
Yeah. So when you say that the user don't have to train their own models, so for example, for computer vision, there can be various use cases.
Yeah.
So let's say I pick up one from the service.
Mm-hmm.
So how do I make sure that I get the best performance from?
Right. So what we can say is those models we keep updating, optimizing those models. So those models will perform better over time, right? But it's really not designed. It's for a quick application, right? You can quickly demo or build the prototype, or I think most of them perform pretty well. I don't have the number, right, benchmark number to show you, but most of them I would say perform pretty well in different industry. If you see your use case, you want to see, I want to use a better model, or I want to build my own model. I feel confidence. I have this benchmark metrics, right? The number I show, I have the confidence on the model performance. So SageMaker will be the tool you're going to use. So you don't use those managed AI services. You use SageMaker. You build your own model, deploy and provide endpoint you can use, and you know the number, the benchmark, the accuracy, right? You have confidence upon that. So this will be the tool you're going to use to build your own model, SageMaker. So I'm going to show you talk about SageMaker. There's a couple of features or modules I want to cover. First of all, this is a SageMaker is IDE, so it's like it's a cloud-based IDE, right? Like your desktop Eclipse or something like that. It has all the tools. It's an extension to Jupyter Lab. So Jupyter Lab is open source, right? Web-based browser. It extend have more function to that. So add the SageMaker SDK, the more APIs. But for people who are already familiar with the Jupyter, they should SageMaker should look familiar to them. SageMaker has a different feature module to cover all the machine learning steps, right? Starting from preparing data, build model, train, tune model, and deploy model, monitor model performance. I think Ryan talked about that early today. I don't want to spend too much time. I just want to show you this diagram. So this diagram, basically, you can see on the top, it shows different phase of machine learning lifecycle, right? Process data, right? I have the data, I have idea, I want to do something intelligent or smart on top of that data. I need to process the data first, right? Processing data, including data mining, cleaning, transformation, integration, and also data labeling. If I want to build a supervised machine learning model, let's say classification or regression, I need to label them. So I can use this label to train the model to predict what I want to do, right? So labeling also very important. And then I can develop model. Develop model means I want to find the right algorithm. There are plenty of algorithms out there, open source. I want to find the parameter. So each model will have parameter, right? If you do deep learning, you all know there are hundreds or even more parameters we want to tune. So that's how we call machine learning model training, right? And deploy the model. Finally, when I feel confident about the model, I want to put API on top of it, so I can call the API. I can run this model online, or I can do batch transformation, right? I have data, I just send it to the model and get the result back. Deploy and monitor. So that's the top line, show you different phase. And the bottom, you can see these are SageMaker components can help you. So those components already done undifferentiated heavy lifting work, help you for each phase of this machine learning lifecycle. So you will be able to find it as you can see it's the ML ops. So there's idea people call ML machine learning ops. Since there's a lot of operation to make a machine learning project in production, push it to production, a lot of operation. And SageMaker help you to do that ML ops from data preparing, training, deploying, monitoring. Yeah. If you have any questions, feel free to stop me. I can quickly show you a couple of examples. Right, our customer, first, this one is our customer, this is UCSD, radiology. So when COVID first started, the pandemic first started, they feel there's a spike of volume. Patients want to run this medical imaging test and diagnose if it's COVID or not, right? The volume kind of spike. Radiologists don't have enough time to do that, to review every slide of image, right? Takes time, and they have the idea, we want to build a machine learning model to help us to diagnose COVID. Yeah, it's pretty mature machine learning use case. This is a very competitive space, I would say. A lot of companies spend a lot of money and effort to do that. So for this example, UCSD, they developed a model on AWS using deep learning model, and they use model in production. This really in hospital scenario, they use it as a secondary capture. So whenever there's a new image generated, they first run this model to capture those potential those features very important to identify COVID, capture them and send this to doctor. Doctor will be much easier for them to see this is a COVID or not, with all those help. So machine learning is not designed to replace radiologists or doctors. It's really help them to make their work more efficient or more productive, right? They can spend less time on each image or use case, and they can review more images, and diagnose for more patients, right? So this is one use case. This is the use case we have built called image search. Since there's a large volume data grow exponentially, right? Large volume of medical image generate every day. But for doctors, they may want to see the similar image. Let's say I know I have seen a patient previously, maybe a couple of years or a couple of months ago, a similar image. I want to see what have been diagnosed for that image to help me to understand what happened here and happened now. We can do image search. And so the image search idea, basically, the image is unstructured data, right? They are image, computer don't understand that. We can convert those images into structured one, the vectors. So vector can be computed. There are plenty of methods to compute vector, similarity, right? Cosine and so on. So we can convert the image into vectors and do similarity search. So that's the idea for this project. And finally, the last project I want to talk about is this called Smart Data Center. So when COVID started, right, people want to quickly test, get idea whether people got infection or not, right? Or likelihood, how likely they got infection. So there's a very smart people, right, in academia. They found we can use voice to detect COVID because it's really like coughing, right? Reading numbers. Those voice feature, audio feature are those fingerprint are very, I would say, very good signal to detect COVID. We don't need to run biological tests to do that. So if we build a machine learning model like that, if we collect, so there's a project running in Cambridge and another one in India. They collect those audio files. They label them, COVID or not, right? There's some other metadata, male, female, age, demographic information, and those data open source. So we use that open source data. We trained a machine learning model, binary classification, right? Yes or no. And when we build this model, we can apply it to a contact center use case, right? When people call in, like hospital, I want to schedule appointment, right? I want to do this annual check or something like that. It's pretty straightforward, just like there's a chatbot asks for, oh, before you come here, can you, we want to run some audio test, like coughing, can you read number 1 to 10? And having that recording, we can basically have idea whether there's a potential or whether there's a likely COVID patient or not, right? And we can have a triage rules. If we feel this kind of COVID, we say, oh, there's other protocol need to follow. You're not supposed to come immediately. We need to do further testing or maybe call back a couple of days or later. Well, now the testing approach, we do have at-home test, right? There's something different, but this approach still pretty useful, helpful when we work with academic medical centers. Their contact center volume kind of spike during COVID pandemic, right? Pretty helpful to help them to reduce those certain cases, reduce volume, and automate this triage process. So a project like that, you see, once you have the data, you have the idea, the machine learning, how it can be helpful. You can apply in any domain you're working, like material engineering, right, or other domain. If you think, oh, if I can use machine learning to automate the process, to increase productivity, you can do that. And AWS has tool, you can easily integrate it with other other process like a contact center, right? Apply it, right? So this solid integration, the foundation AWS provide, you cannot get it from any other place. You got the machine learning idea function, use it in production pretty fast. AWS can help you with that. So that's pretty much I want to talk about AML on AWS today. If you have any question, comment, feel free to stop me. There's some other topic I want to cover, like research collaboration and open data program. So if you don't have any question, I'm going to move on. First, I talk about research collaboration. So that in research, right, there's a different role. People play in different role. There's a research IT folks. They want to provision the resource for you to run your research. And there's researchers, right? Their focus and their the feature they would like the platform to have are different, right? The IT folks think about security, how to make sure I have a governance over this platform. The researcher think about how I can easily access using federated login. I can share my research project with other. I want to collaborate with other, and also spend control, right? I want to see how much money I spend on each project. So to answer those questions, I believe there were questions asked about like I want to see spend, right? I want to see cost. AWS we have budget, right? But not a research use case specific this cost view, right? But there are other tools available for you running on AWS. You can get the visibility of your cost using the other tools. One of the two is a service workbench. So this is an open source tool. So there's a UI interface. You can use this tool to log in to run, spin up AWS resource on the compute resource on AWS. You can also gain cost, gain this visibility on the cost allocation, right? How much money I spend on different projects by different teams. You can get that information using this tool. So at the last but not least, I want to quickly talk about this open data, AWS open data program. So we touched this topic early in the morning, right? And there's a question about, I want to transfer data, right? I want to transfer data to different region. I want to transfer data between data center, right? Transfer data back to our own supercomputer center. Well, it's possible, right? We do have the egress waiver to allow this data transfer is fast and cost efficient. But the really idea for this open data program is we want to bring compute closer to data, right? The data can be huge, right? Terabytes, hundreds of terabytes of data. You don't want to move data around. You don't want to get multiple copies of those data. You want to run your compute closer to data, and those compute can be elastic. I can spin up on demand. I can turn it on and turn it down, just like I use electricity, right? So that's the idea for open data. And the data is already available on AWS. There's last time I checked, there's 320 open data set. There's a cover different research domain. Data already there. What do you need? Just the AWS account. I can create compute, right? Either EC2 or container, HPC or Lambda. You have learned early today. You can run those compute on top of the data, right? Data already there. So that is pretty much I want to cover today. And there's a resources. If you search for machine learning AWS, you will go to, most likely you will land this page to get resource for you, right? Talk about the machine learning on AWS, or talk about healthcare on AWS, the use case and the reference. That's pretty much it for today's talk. And I highly recommend you get you, there's a training opportunity available, right? Like what Scott showed earlier, right? And we can do hackathon or office hour if you have questions. So I would recommend get your hands dirty, right? Think about idea in your mind, what you want to build, and feel free to reach out to us. That's it. Thank you. We do have questions. Well, I feel you are pretty focused. Yeah.
One question is going back to that transcribe service. I think it should be doable too, because like some people naturally speak multiple languages in a conversation.
Right.
When they know multiple languages.
Yeah.
And in natural language processing now, a lot of the text embedding models are being trained on multilingual data sets, like AI and stuff like that. So they're able to get the feature vectors for text regardless of the language it's in. So I'm not sure why. So I think it should be possible to do that transcription service in that sort of sense.
I agree with you. I think the service team, they are already working on something like that. It's just not currently available.
Okay.
Yeah. We may get that maybe in the next reInvent meeting or next couple of Cool. I just have one book. I do have a lot of good questions. Appreciate. Thank you for your attention and your questions. So, anyone really want it or you want? Okay, sure. Cool. Yeah, no problem. Great. Yeah. And we are around. Feel free to talk to us. Thank you. I know where it is.